You ever had that feeling, that specific kind of digital frustration? You type everything perfectly into one system, you hit save, you think, great, done.
And then nothing. Or, maybe worse, it pops up totally wrong in the other system it's supposed to feed into.
Exactly. It confuses everyone, maybe grinds some other process to a halt. It's that maddening lack of, well, conversation between the digital tools we use every single day.
It really is a silent productivity killer in so many places. We build these amazing, powerful systems, but the second they need to actually interact, share data, trigger actions, stay synchronized, that's where the complexity just explodes.
It's not just annoying. It can genuinely break core business functions.
Absolutely.
And often, the folks trying to figure out why it's breaking, or maybe building those digital bridges in the first place, are the database administrators, the DBAs, working away behind the scenes. So, welcome to the deep dive. We've gathered a whole stack of sources for this one, looking at the core DBA job, the nitty-gritty of connecting systems using things like APIs, and importantly, practical ways to troubleshoot when those connections inevitably go wrong.
Yeah, our goal here, our mission really, is to cut through some of that complexity for you. We want to pull out the essential bits of knowledge about why integrating systems is just so tough.
Show you the common traps people fall into.
Right, and maybe give you the mindset and some tools to become a bit of a digital detective when things do get tangled up. Think of it as a shortcut to understanding not just what DBAs do day to day, but how vital their role is in this messy, interconnected world of modern systems.
Okay, so let's kick off with the fundamentals based on what our sources say. What does a database administrator actually do?
Well, at their heart, DBAs are the guardians of an organization's data. They look after the databases, where all the critical information lives. Their job is making sure those databases are running smoothly, that people can access the data when they need it, that it's safe from threats.
And that the data itself is actually reliable and accurate. That sounds pretty crucial.
It is. And reading through this material, it sounds like a seriously demanding role. They're almost expected to know, well, everything about everything related to data flow, not just their specific database technology.
Yeah, the sources mention long hours, often over 50 a week, right? Including nights and weekends for maintenance when systems need to be offline.
And here's something that really jumped out from the sources. When an application goes down, the database is almost always the first thing people point fingers at.
The guilty until proven innocent syndrome.
Exactly. It really underscores how critical that database infrastructure is, but also how often it gets the blame, sometimes unfairly.
That's immense pressure. And you can see why they get dragged into integration problems when you look at the sheer range of their responsibilities listed here. Database design, figuring out the data structure itself.
Performance monitoring and tuning, making sure things run fast.
Ensuring availability, literally keeping the lights on for the database.
Database security and authorization, guarding the data.
Governance and compliance, dealing with rules like GDPR or IPOT.
Backup and recovery planning for disasters.
And, super relevant for us today, ensuring data integrity, making sure the data itself is correct and consistent.
Precisely. And the sources also mentioned that, while some larger places might have dedicated data administrators focusing purely on the meaning and models of the data, the metadata, the conceptual stuff often, if those roles aren't there, the DBA picks it up.
So they're not just managing the pipes. They're often involved in defining what's flowing through them.
That's a good way to put it. They often have to understand the business context of the data, too.
And it's probably worth noting, one of our key source authors here, Craig Mullins, has decades of hands-on experience with all sorts of systems, DB2, Oracle, SQL Server, across different industries. That really grounds the advice. It's not just theory.
Absolutely. That real-world perspective is vital because database skills, while foundational, are increasingly needed in these really complex, interconnected scenarios we're talking about.
Which leads us right into the main event. Why is system integration so darn difficult? The sources are pretty clear. Systems hardly ever live in isolation anymore. They have to interact, and that interaction point is where the complexity multiplies.
Oh, definitely. And one of the biggest headaches, highlighted again and again, is simply data everywhere, and none of it agrees. The key thing here isn't just moving data from A to B, it's managing the meaning of that data, the semantics, and maintaining trust across different system boundaries.
Just think about it, right? System A calls something customer, System B calls it account number, System A uses one date format, System B uses another, trying to map and transform between all these different structures, CSV files, JSON, maybe unstructured text. feeding into a relational database.
The anatomy of the heart sources really drive this home. It introduces huge risks. Errors just creep in so easily. Data gets lost, maybe corrupted during the transformation. And if you get an inaccuracy in one place...
It can spread like a virus through the whole organization.
Exactly. Data consistency and accuracy should be the top priority. The sources stress this. But actually achieving that when you're dealing with different definitions, different formats, it's exceptionally hard. It needs constant vigilance, data profiling, cleansing, validation rules.
Not just a one-off mapping exercise.
No, definitely not. It has to be ongoing.
Okay, hurdle number 2. Building for growth, scalability, and flexibility. Integrations can't just work for today's load. The business grows, data volumes balloon, transaction rates go through the roof. If your integration wasn't designed with that kind of future growth in mind...
It quickly becomes a major bottleneck, a liability. The sources are really emphatic about this. Older methods, or maybe rigid, custom-coded solutions that weren't built for scale, they just buckle.
Performance tanks, errors start popping up everywhere.
And you're stuck with this brittle system that's incredibly expensive and painful to re-engineer later. The core message seems to be, don't just build for now, assume significant growth. Design that scalability and flexibility in from the start.
Makes sense. And you can't possibly discuss systems connecting without keeping the gates secure, security compliance. A weak integration point is basically like leaving a door wide open for attackers, isn't it?
It absolutely is. It creates new potential attack surfaces, potentially exposing really sensitive data. You have to scrutinize security at every single connection point.
And the common nightmares often start with authentication and authorization, right? Those HTTP 401 errors, trying to figure out complex OE flows, maybe just mishandling API keys.
All of those can bring integrated processes to a dead stop. And then you layer on top the whole compliance piece, GDPR, CCPA, IPA, whatever applies. Those rules follow the data across system boundaries. You have to ensure compliance throughout the entire chain.
It's a minefield.
It can feel like it. And connecting this back to people, one of the anatomy of the heart sources makes a great point. A lot of these technical integration failures are actually symptoms of deeper human and process pitfalls.
Like unclear requirements from the start.
Exactly. Or maybe not having the right mix of expertise across the different teams involved. Scope creep is a classic one. Or just, fundamentally underestimating how complex the integration really is.
That's a critical insight.
Yeah.
Sometimes organizations treat integration like it's just an IT plumbing job.
Right. When the sources argue it's actually a business-critical initiative. It needs buy-in across departments. It needs strategic oversight. If you just see it as wiring A to B, you miss that crucial alignment.
And that misalignment probably fuels the technical problems down the line.
It's often a vicious cycle, yeah. Poor processes lead to rushed or messy technical solutions, and that technical mess makes it harder to fix the underlying process problems.
Okay, so let's zoom in on one of the main ways systems do connect these days. APIs, application programming interfaces. Our sources focus quite a bit on these, especially REST APIs.
Yeah, REST APIs have become a sort of standard way for systems to talk. They follow principles like separating the client and server, using standard web addresses, URIs, to identify resources, using those common HTTP verbs like get, post, put, delete.
Get data, create data, update data, remove data.
Right. And exchanging data usually in formats like JSON in the request body or the response. The Salesforce REST API gets mentioned as a common example.
But as you hinted, they come with their own set of quirks and potential issues. First hurdle you usually hit: authentication and authorization. Get this wrong, and nothing works.
Nothing. And the sources list those common HTTP status codes you'll inevitably encounter. 400 bad request, 401 unauthorized, 403 forbidden, 404 not found.
429. Too many requests. We'll come back to that.
Right.
500 internal server error. 503 service unavailable. Just recognizing these codes is half the battle in troubleshooting.
It really is. And the sources detail different ways APIs handle auth. Simple API keys, basically passwords, need to be kept super secret. OAuth 2.0, more of a framework, using access tokens and defining permissions or scopes.
And JWT's JSON web tokens, those signed tokens that carry information.
Exactly. Signed bearer tokens with claims inside. Validating that signature is absolutely critical. And the sources specifically warn: never use the none algorithm in JWTs, and generally follow security best practices like the OWASP API Security Top 10.
Good tip. Okay, another big one: rate limiting. That 429 error. APIs often restrict how many requests you can make in a certain time period.
Yeah, to prevent abuse and keep things fair for everyone using the API. So how do you handle hitting those limits? The sources suggest a few strategies. First, be reasonable with your own request rate.
Don't hammer the API unnecessarily.
Right. And then implement retry logic, but smartly. Use something called jitter.
Jitter.
Yeah, add a bit of randomness to your wait time before retrying. If everyone retries exactly 1 second after getting rate limited, they all hit the API again at the same instant. Jitter spreads out those retries.
Ah, clever. Avoids the thundering herd effect.
Exactly. Also, monitor your failures, log them, and maybe adjust your retry strategy based on the error code. Like a 404 not found, probably no point retrying that over and over. A 500 server error, maybe that is temporary, so a few retries make sense.
Got it. Then there's versioning. APIs change over time. How do you update an API without breaking all the applications that already rely on the old version?
That's a huge challenge. The sources talk about different ways to signal the version, putting it in the URL path, like V1 products, using a query parameter like .version1, or using a custom HTTP header like XAPI version.
Pros and cons to each, I imagine.
Yeah, trade-offs around simplicity, how well they work with caching, how cluttered the URL looks, things like that. But the really crucial advice from the sources is about managing the change itself gracefully.
How so?
Try to maintain backward compatibility if you possibly can. Avoid making breaking changes to existing versions. Instead, maybe add new optional properties or entirely new endpoints for new functionality.
And communication is key, I bet.
Absolutely critical. Provide clear documentation, detailed change logs, and have a clear deprecation policy. Tell users well in advance if an old version is going away. Give them timelines, support them through the transition. Don't just pull the rug out.
Right. Okay, one more API-related pattern. Webhooks versus polling. How do systems find out when something new happens?
Good question. Polling is the classic approach. Your application keeps asking the other system anything new, anything new, anything new, like constantly knocking on the door.
Which sounds inefficient, especially if updates don't happen very often.
Exactly. Webhooks flip it around. It's more like the server calls you when there's an event. Hey, this thing you care about just happened. Here's the data.
That sounds much better. More efficient, more real time.
Generally, yes. More scalable, too. But the sources highlight a key responsibility for the system receiving the webhook. You need to acknowledge you got it almost instantly. Send back a quick 200 OK status within a few seconds.
Why so fast?
Because the system sending the webhook can't wait around forever. If it doesn't get that quick acknowledgement, it assumes the message failed and it'll probably try sending it again.
Causing duplicates or unnecessary load.
Right. So the common pattern is acknowledge immediately, then put the actual data processing onto a background queue, like using SQS or RabbitMQ, to handle asynchronously. Don't try to do heavy lifting while the sender is waiting for that obey.
Gotcha. And sometimes there's a setup step too.
Yeah, some providers require a sort of handshake or validation process when you first set up the webhook endpoint to prove you own it. It's a fundamental difference in architecture. Polling versus push webhooks.
Okay, so integrations are tricky, APIs have pitfalls, stuff will break. Time to put on the digital detective hat. How do you troubleshoot these tangled systems?
Well, the sources frame troubleshooting not just as fixing a bug, but as an iterative learning process. It's about finding the immediate fix, sure, but also documenting what happened, learning from it, maybe adjusting systems or processes to prevent it happening again, building up that institutional knowledge.
Because these failures rarely happen in a vacuum, right? The symptoms can ripple out everywhere.
Exactly. So the detective's first move is often isolation, the classic divide and conquer strategy. Can you pin down where the problem lies? Is it the client application sending the request? Is it the network in between? Is it the server or API on the other end?
How do you isolate like that?
Techniques like mocking or stuffing dependencies are key. You basically create fake versions of the other components. Pretend the network is perfect. Does the client work? Pretend the downstream API always returns success. Does your part work?
Okay, simulate the environment around the piece you're testing.
Right. And tools are your friends here. The sources mention things like Xdebug for stepping through Kite and PHP, or tools like Postman or curl to manually craft and send API requests, bypassing your main application entirely. That helps isolate if the issue is in your code or the API itself.
Essential tools for the detective kit.
Definitely. And the detective's most vital resource, information, evidence. That's where the power of logs and metrics comes in. You simply cannot troubleshoot complex integrations effectively without good visibility. Continuous monitoring isn't optional.
Let's break that down. API logs. What are they telling us?
They're the narrative of every interaction. The sources talk about different types, access logs, who called what when, from where, what was the outcome, error logs capturing exceptions, failure details, error codes, messages, performance logs, how long things took, resource usage, security logs, authentication attempts, potential threats.
That's a lot of logs.
It is, and that leads to the most critical insight here from the sources. Centralized log aggregation and standardization. You absolutely must collect logs from all different systems involved into one central place.
Otherwise, you're hunting through dozens of separate log files.
Exactly, and they need a standard format so you can search them effectively, and crucially, you need correlation IDs, a unique identifier that gets attached to a request when it starts and follows it through every single system it touches.
So you can trace one specific user action or transaction across the entire chain.
That's the only way to do it reliably. Without correlation IDs, connecting the dots between logs from different services is a nightmare. Tools like Synios, the ELK stack, Graylog, FluentD, Splunk, these are your central evidence lockers for logs.
Okay, logs tell the story. What about API metrics?
Metrics are more like the system's vital signs, numerical measurements, response time, throughput, request per second, error rate, system availability, uptime. They quantify how things are performing overall.
So logs are the narrative, metrics are the dashboard indicators.
Good analogy. And then you have APM, application performance monitoring tools. Think of platforms like API Toolkit, Datadog, Sentry, New Relic, Splunk APM. They pull together all this telemetry, data logs, metrics, traces, which show the path of a request in real time.
Giving you dashboards, alerts.
Right. Helping you spot anomalies, performance degradation, and drill down into the potential root causes across your entire application landscape and infrastructure. They provide that kind of X-ray vision into the black boxes. Without these tools, you're often debugging blind.
Makes total sense. Okay, let's get specific. Troubleshooting data quality issues again. If data's not flowing right.
The detective needs to perform data profiling. That means examining the data itself, both before it goes into the integration and during the process, looking for anomalies, inconsistencies, duplicates. Then comes data cleansing, fixing the bad data, and implementing data validation rules, automated checks, either in the source system, maybe in the integration layer itself, or even in the target system like Salesforce to catch bad data before it causes problems.
Proactive defense against bad data.
Ideally, yes. For API failures, the playbook outlined in the sources usually starts with check the API documentation. What does that error code actually mean according to the provider? Then meticulously validate your request headers, body parameters. Are they exactly what the API expects?
Use those tools like Postman or curl again.
Yes, try to replicate the failing request outside your application. If it fails there too, the problem is likely with the request itself or the API. If it works there but fails in your app, the problem is likely in your code. And then, crucially, dive into those correlated logs. Follow the correlation ID through the auth logs, request logs, any transformation logs, error logs. Find the exact step where it went wrong. Was it auth, rate limiting, invalid data, a failure in a downstream service the API relies on?
Don't forget checking specific dashboards too, right? Like the customer.io example mentioned.
Good point. Many integration platforms provide their own dashboards showing connection health and recent errors, which can be a quick first check.
And finally, security troubleshooting. What are the key things there?
Checking authentication logs is vital. Are tokens expiring? Are attempts failing? Why? The sources also reiterate secure logging practices, huge one. Never ever log sensitive data like passwords, full credit card numbers, or API keys in plain text. That turns your logs into a security risk themselves.
And addressing vulnerabilities isn't just code fixes.
Right. It might be configuration. Are endpoints exposed that shouldn't be? Do they need stronger authentication, maybe IP whitelisting or mutual TLS? Also, watch out for verbose error messages that might leak internal details about your systems to potential attackers. Errors should be helpful for debugging, but not too informative externally.
Okay, if we pull all this back together, you can really see how the DBA fits into this picture, even if they don't own every single piece.
Absolutely. Bringing it full circle to the DBA role, while they might not be writing the integration code or managing the API gateway directly, their deep foundational knowledge of the database, which is so often the source or the destination of the data being integrated, is indispensable.
Those core DBA tasks we talked about earlier, performance tuning, ensuring availability, managing security, maintaining data integrity.
They're not just tasks done in isolation anymore. They are directly impacted by integrations, and they are absolutely critical for the success of those integrations. If the database can't handle the load from an integration, or if it's not available, the integration breaks. Period.
And the sources suggest DBAs are increasingly working side by side, shoulder to shoulder, with developers, sysadmins, data admins.
Yeah, collaborating to diagnose and fix these complex cross-system problems. It requires that broader perspective, understanding how their database fits into the whole ecosystem, not just managing the server in a silo.
It demands both deep specialization and that collaborative system-level thinking.
It really does.
So wrapping this up, what does this all mean for you listening? We've taken quite a journey through the world of database administration and peeled back the layers on system integration challenges. It's clear the complexity is real. It's about data, meaning scaling problems, security risks, even people and process issues.
But I think the key takeaway from digging into these sources is that while the challenges are significant, they are manageable. It starts with having the right mindset, thinking like that digital detective.
Leveraging those proactive strategies, good logging, solid monitoring.
Using the right tools for isolation and analysis and really fostering that collaboration across different teams. With those things in place, you can navigate this tangled web much more effectively.
Yeah. And we definitely encourage you to maybe dig deeper into areas that sparked your interest today. Maybe look up the OWASP API Security Top 10, research some of those logging or APM tools we mentioned, or perhaps explore data modeling and validation techniques in more detail.
And it leaves us with a thought, doesn't it? As systems get ever more connected and these integration challenges become more common, how is this changing the roles of IT pros like DBAs? They need to be more than just database managers. They need to be expert navigators, troubleshooters of these sprawling digital ecosystems. So what are the next critical skills they'll need to master? It's a landscape that just keeps evolving, keeps demanding more.